This is the final video for Unit 12, Lesson 1. As we go through examples 10 through 16, I'd like you to pause at the beginning of each problem, attempt the problem, and then come back to the video to see if you correctly answered the question. Our goal is to find the value of x by solving the trigonometric equation. Remember that our x will be as low as 0 pi and it will go up to 2 pi, but it will not be considered as a solution. Let's get started. So the nice thing about this is notice I only have a 1 in front of the x. So I'm only doing one revolution. And so as I'm solving here for x, my first step is going to be to add the square root of 3 to the opposite side. And now I'm dividing by 2. I have the cosine of x equals the square root of 3 over 2. Now I want you to begin to practice without using that unit circle. So myself, I'm going to be kind of lazy here. I'm going 1, 2, 3, 1, 2, 3. Throwing 2's on the bottom of everything and knowing that on top I have the square. Okay, cosine is the first number, so that's right here. It's a positive value. All-Star Trig class puts cosine values are positive in quadrants 1 and in quadrants 4. So I'm looking at these two positions. That would be x equals pi over 6 and x equals 11 pi over 6. Now how can we check to see if we're correct? Well, the first thing is making sure that we are in radians. I'm going to come up here to cosines in parentheses. Let's try the second one. It doesn't matter which one we choose. Divided by 6. And then I'm going to subtract the square root of 3. And I better get an answer of 0. You know what I did? I forgot to use the pi symbol. Let's try this again. 2 cosine in parentheses. Let's remember that pi symbol. And now I'm going to subtract the square root of 3. And this time we get an answer of 0. Let's move on to example number 11. Example number 11, again, notice I only have one revolution to do. This time I'm going to subtract, so it looks very similar to the first example we did in this video, example number 10. The difference is now I have a cosine value that is negative. So where are cosines negative? Cosines are negative in quadrant 2 and in quadrant 3. I'm still looking at a reference angle of radical 3 over 2. So radical 3 over 2 for a cosine has a reference angle of 30 degrees, or pi over 6. In quadrant 2 and in quadrant 3, that reference angle would put us at x equals 5 pi over 6 and x equals 7 pi over 6. Again, how can we make sure we did it correctly? It doesn't matter which one we use. Let's come up here and we have 2 cosine. In parentheses, let's go with 5 pi divided by 6, and now I'm going to add the square root of 3. We get an answer of 0 and feeling confident with my answers. Let's look at example number 12. Example number 12. Now this time we don't have one of the primary trig functions, sine, cosine, and tangent. We have one of the secondary trig functions. I'm going to start by subtracting 6 to the opposite side, dividing by 3, and then simplifying this. So I have the cosecant of x equals negative 2. Now I recognize that cosecant and sine are related. They're reciprocals of one another. This means the sine, it keeps the same sign, is negative 1/2. Where are sine values positive? All-Star Trig class tells you that sines are only positive in quadrant 1 and quadrant 2. So I'm looking at quadrant 3 and quadrant 4. I'm going to come back up here and let's first just identify where is the sine 1/2. That's going to be again a reference angle of 30 degrees, or pi over 6. So I have a reference angle of 30 degrees, but I need to land in quadrants 3 or quadrants 4. That's putting me right down here at 7 pi over 6 or 11 pi over 6. Let's make sure I correctly answered this question. So I'm going to type this in as 3, and now I want 1 divided by the sine. In that position I can try either one. Let's try 7 pi divided by 6, and then I want to add 6 to this, and I better get an answer of 0. So think of this. This is 1.2, and we're going to go backwards 1, 2, 3, all the way back here. That's basically 0. Let's try the next one. 3, and I have 1 divided by the sign. Again, I'm going to go with 11 pi divided by 6, and I'm going to add 6 to this, and we get an answer of 0. This, in scientific notation, is basically 0. So they both work out. Let's look at example number 13. Now, this is not a 2, it is a square. Keep that in mind. That does not say 10 cosine 2x. It's cosine x squared minus 5. So we're going to start by adding 5 to the opposite side. I'm going to divide by 10. And now I'm going to take the square root of this. Cosine of x equals plus or minus. We know the square root of 1 is 1. And we have the square root of 2. Mathematically, none of this is wrong, but it's not in proper form. So in proper form, we're going to multiply both the top and the bottom by the square root of 2. 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is the square root of 4, which is simply 2. Okay, so I know that I can find in my 3 common angles here of 30, 45, and 60, I know at 45 degrees, which is pi over 4, I can find a cosine value of radical 2 over 2. That's my reference angle. Now here's the thing, it says positive and negatives. So all star trig class says the cosines are positive in quadrant 1 and 4, and the cosines are negative in quadrant 2 or 3. So I'm looking for 4 different places that have this, the reference angle of 45 degrees. That would occur, notice there's only a 1 in front, that would occur at pi over 4, at 3 pi over 4, at 5 pi over 4, and at 7 pi over 4. Is there a way to ensure we did this correctly? Well, let's grab our calculator. We have 10 times the cosine. Now I can choose any one of these. Let's try 5 pi over 4. 5 pi divided by 4. I need to square this quantity and then subtract 5, and I should get an answer of 0, which I do. Let's go on to example number 14. Again, this is not 2x, this is secant squared. I'm going to start by adding 20 to the opposite side, dividing by 5, taking the square root. I get 2 answers because of the square. The square root of 4 is 2. Like example number 12, secant is not one of the primary trig functions, sine, cosine, and tangent. But I recognize that secant is the reciprocal of cosine. So the cosine of x is plus or minus 1/2. Where do I find that? Well, let me draw. I have 1, 2, 3, 1, 2, 3. 2's are on the bottom. Square root, square root, square root, square root. Okay, where is the cosine of x equal to 1/2? That's going to be cosine is the first value. That's going to be a reference angle of 60 degrees or pi over 3. Now, because I see plus or minus, I'm looking at all 4 quadrants. All-star trig class puts cosines positive on top and negative in quadrants 3 and 4. So my areas will be at pi over 3, 2 pi over 3, at 4 pi over 3, and 5 pi over 3. Those are my 4 solutions. And I can prove this by typing in 5 multiplied by it. Now secant is 1 over cosine, so 1 divided by the cosine. I'm not going to put in that square right now. I'm going to choose any one of these. Let's try 5 pi over 3. 5 pi divided by 3. I'm going to square that entire quantity, and then I'm going to subtract 20, and I should get an answer of 0, which I do. Let's go on right now to example number 15. Remember, I want you pausing, attempting, and coming back to the video. We have 2 things here. We have this quantity squared and a 2x. So there's 2 things to consider here. Let's start by dividing by 4. So I have sine squared of 2x equals 3 divided by 4. I'm going to take the square root. Remember, this means 2 answers. So I have the sine of 2x equals the square root of 3 over the square root of 4. But don't forget, there's a plus or minus because of the square. Now, the square root of 3 is an irrational number. So we're going to leave that as just the square root of 3. And the square root of 4 is 2. I can see right now if I move up here, and I don't have to redraw this, I know sine is the second value, and I can see at 60 degrees, or pi over 3, is where I can locate this. Now we have plus or minus, so 60 degrees is my reference angle, but I'm going to have 4 of these because I'll have plus or minus, right? I'll have plus or minus. So let's write these down. I have the positive signs at x equals pi over 3 and at x equals 2 pi over 3. I have the negatives occurring at 4 pi over 3 and also at 5 pi over 3. Now, I have to do 2 revolutions. This is only 1 revolution, but let's start with the first revolution. Dividing by 2 is the same thing as multiplying by 1/2. So I end up with pi over 6. I believe that's one answer. When I multiply by 1/2, the 2's will be reduced, and I'll be left with pi over 3. Again, multiplying by 1/2, I get x equals 4 over 6. Well, that reduces to 2 pi over 3. Multiplying by 1/2, I get x equals 5 pi over 6. I believe that's the first revolution of answers. Let's go up and make sure that I correctly did this. I still need to do a second revolution. Okay, you ready? Let's try. 4 parentheses, sine of 2. Now I can choose any one of these answers. Let's try 5 pi over 6. It's important that you make sure your calculator is in radians. Now I need to take 1, 2, 3, 1, 2, 3. I need to square this entire quantity. And then after I square it, I think I have everything here actually, don't I? So I have 4 sine squared of 2 times this quantity, and we want that to equal 3. Let's see if this equals 3. It does. So I feel confident in these answers. Now I need to do a second revolution. Let's make sure I have room down here. So this is my second revolution. We can easily do this by counting by 3s. Watch. 1 over 3, 2 over 3, 3 over 3, here's 4 over 3 and 5 over 3, 4 over 3, 5 over 3, 6 over 3. Now I'm going to do my second revolution. Here's 7 pi over 3 and 8 pi over 3, 9 pi over 3. Here's 10 pi over 3 and 11 pi over 3. Okay, so again, in the same fashion I did the first revolution, I'm going to multiply by 1/2. So I believe one answer is 7 pi over 6. I believe another answer, well, if I multiply by 1/2, I'd get 8 over 6. 8 over 6 is going to be the same as 4 pi over 3. Here, if I multiply by 1/2, I'd get 10 over 6. Well, 10 over 6 is the same as 5 pi over 3. And over here, if I multiply by 1/2, I get an answer of 11 pi over 6. Again, we could choose any one of these. Let's try 4 pi over 3, and let's make sure it works. 4 parentheses sine of 2 times, I'm going to try 4 pi divided by 3, and then I need to square it, and I want it to equal 3, whoops, and it surely does. Let's look at example number 16. In example 16, I'm going to set each factor equal to 0. I'm going to start by drawing arrows here. So I need to do 3 revolutions. Tangent of 3x equals 0. And I'm going to grab my unit circle. I'm being lazy here. And I want to ask myself, where is the tangent equal to 0? Okay, so it's equal to 0 here at 0 pi. So remember, we can include 0 pi. So it's equal to 0 at 0 pi in my first revolution and also at pi. So 3x equals 0 pi and 3x equals 1 pi. Now I need to do 3 revolutions. There's my first revolution. I'm going to go horizontally. Now my second revolution, so 0 pi, 1 pi, and then we'll go 2 pi and 3 pi. So 2 pi and 3 pi. And now my third revolution will be at 4 pi and 5 pi. And I'm going to divide each of these by 3. I end up with x equals 0 pi, x equals pi over 3, x equals 2 pi over 3, x equals 1 pi. Oh my goodness, Aaron. x equals 4 pi over 3, and x equals 5 pi over 3. Remember, each of these should equal 0. So let's, oh my goodness, let me pause this. All right, let's try any one of these to ensure that this is working. I already know that I am in radians. Let's come up here, typing in tangent of 3. I can choose any one of these. Let's try here with pi divided by 3, and I want an answer of 0. I receive an answer. Again, I can show you another one. Let's try 5 pi over 3. So if I have the tangent of 3 of 5 pi divided by 3, and you can see again I get an answer of 0. Let's go on to the next part. So taking the second factor, tangent squared x, this is not 2x minus 3 equals 0. I'm going to start by adding 3 to the opposite side, and now taking the square root. Remember, I will have a plus and a minus, so plus or minus the square root of 3. Now you have to remember, where is the tangent equal to the square root of 3? That's at a reference angle of 60 degrees, or pi over 3. Because it's plus and minus, we're going to hit all 4 of these that have a reference angle of pi over 3, or 60 degrees. That would be each one of these locations. I'm only doing one revolution. So I believe the answer is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. How can I ensure that I did that right? Well, let's choose any one of these. Let's start with 4 pi over 3, and let's plug it in. So I have tangent. I'm going to plug in 4 pi divided by 3, make sure I'm using parentheses correctly and squaring it, and then subtracting 3. And we can see this exact same thing. If I take this and I move it to the left 12 places, it's ultimately equivalent to 0. Let's try a different one. We have tangent of, and I need to use that parenthesis, of 2 pi divided by 3. Oh, I forgot to plug it in. Tangent of 2, I am struggling. Tangent of 2 pi divided by 3. I want to square it, and then I want to subtract 3, and we can get the exact same thing of 0.